Hey guys, welcome back. In this video, I'll be showing you how you can create a simple GPS based location tracker using an Arduino board, GPS module, as well as some simple electronic components. I'll be giving you complete instructions including the circuit diagram, the PCB files if you want to make a PCB, and complete codes and explanation so that you can make one yourself. So without further ado, let's get started. I used Alteium Designer to draw the circuit and design the PCB. Alteium is a PCB design tool that can be used to create simple PCBs for hobby projects or complex and multi-layer PCBs for industrial use. An Alteium subscription includes Alteium 365, which lets you design, share, and manufacture your projects everything in one place. You can download and install the trial version from the link in the description below. The Schematic Design centers around an Arduino UNO R4, which is a Wi-Fi powered Arduino UNO board, powered by a 7806 voltage regulator that converts a higher input voltage, for example from 12 volt to 5 volt steady DC power supply. And then we have a GPS module and an MP3 module. Two sets of indicator LEDs right here for 12 volt and 5 volt with current limiting resistors provide visual confirmation of proper power supply functioning. And the Arduino UNO R4 that handles serial communication with the GPS module via RX and TX pins, as well as the module receives power from the 5 volt supply and shares a common ground, enabling location data acquisition. The MP3 module, also powered by a 5 volt, communicates with the Arduino through the software serial TX and RX lines connected to pin 10 and pin 11 of Arduino and outputs audio to the speaker via SPK1 and SPK2 terminals. Additional input includes a switch connected through a resistor to pin A5 and an LED driven by a pin through a 470 ohm resistor, providing extra control and status feedback. For this project, we only need the Arduino UNO board as well as the GPS module for location acquisition. But in the future video, we'll be using the MP3 module and the display module to create an interactive AI-powered tour guide. So make sure you subscribe to our channel if you don't want to miss that. This is just my design guys, but like I said earlier, I will provide the schematics in the description so that you can redesign the entire thing, customize it, and then make your own version of it. Whatever you do, the first thing is to try it out on a breadboard, and once you are getting the output, then you can use it as such or make your own PCBs like I did. Also guys, if you are truly into electronics and PCB, check out Alteium Student Lab. And you can get free access to Alteium Designer and Alteium 365 to work with your friends and earn a certificate recognized by top industries in India. You can use your university or school email to start for free. You can try that as well for free by clicking the link in the description below. So the hardware is ready. Now let's get down to the software part. Here I'll be programming the board using Arduino Cloud. Okay guys, so this is our main Arduino Cloud dashboard. And here under things, you should be able to see all the projects that we have worked on or currently working on. And here you should be able to see this location tracker now. So simply click on that. So here you should be able to see all the information regarding this particular project. So here you can see there are two cloud variables. One is cloud location variable called coordinates, and then we have one string variable called map string. We will be linking this cloud location variable called coordinates to a map widget, and here one thing that you need to make sure is that the coordinates should be of this particular format. Then only the map widget will be able to read the latitude as well as the longitude properly and map the correct position. Okay, so here on the right side you should be able to see the associated device, that is the board that is linked to this particular project, and that is Arduino UNO R4. And below that we have the network name as well as the passphrase for the Wi-Fi network. Now let's take a look at the dashboard. From this top menu here, click on dashboards, and here we have the dashboard that I created. And here as you can see, there are two widgets right now. One is this value widget, which will be giving us an idea about the latitude and longitude, and then we have this map widget which will be plotting the position. Now let's go back to the things, open our project, and on the top right you should be able to see this button called sketch. Simply click on that and that will take you to this coding page. This Arduino code is designed to interface with a GPS module and send location data to Arduino Cloud. The program begins by including necessary libraries like Tiny GPS Plus for handling the GPS data and initializes objects such as GPS for processing location information. In the setup function, serial communication is started to allow data to be read from GPS module and displayed in the serial monitor. Additionally, it initializes cloud communication with Arduino cloud.begin to allow the Arduino to send data to the cloud, and debug information is printed to help troubleshoot any set of issues. In the loop function, which runs continuously, the Arduino regularly updates the cloud connection and checks for GPS data. If GPS data is available, it processes the incoming characters and calls the display info function, which will show the location, date, and time. If the GPS module has not sent any valid data within 5 seconds, the code assumes there is a problem with the wiring and halts further execution by entering an infinite loop. All this data will be updated in the widget that we created earlier. So all we need to do is simply compile it and upload the code to our Arduino Uno board. Now let's go for a walk and see this in action. If you like this project and if you are really interested in building amazing DIY projects, make sure you subscribe to our channel by hitting the subscribe button right here. See you in the next video.